When we report data, we want to report it to the correct number of significant figures. These are used to show the reliability, the precision of your measurement, okay? They show how good your tool was that you used to measure. And so when we talk about significant and numbers that are already reported, we're not talking about whether they're important or not. We're talking about if they help the person looking at the data to understand what kind of measurement it is, how good of a measurement it is. And so just keep in mind that significant here doesn't mean important, okay? It means, does it add to the precision of the measurement? And so we've got some rules for significant figures if we're trying to judge whether or not a number is going to be significant. The first one's really easy. Any digit that's in the number that is not 0 is automatically significant. So if I have the number 41.3 grams, let's say, that has 3 significant figures because all of them are non-zero. Zeros turn out to be where we have some trouble because depending on where they are determines whether they are considered significant or not. So if you have a 0 that's sandwiched between two other numbers, it's automatically significant. So if we have, say, 508 milliliters, that also has 3 significant figures because that 0 is between two non-zero digits. If the 0 comes before the first number, they are not considered significant. They're used to locate the decimal point. They're the placeholders. So if I have 0.04 grams, those zeros, those are leading zeros because they come before the first number, don't count. This number only has 1 significant figure. Trailing zeros, it's going to depend on where they are in relation to the decimal point. If they're after the decimal point, automatically significant. So if I record 37.0 milliliters, that's telling me that I took this measurement on a scale that was marked to the ones place and that it looked like it was exactly on the 37 mark. And so I had to record it to the tenths. I recorded it as 37.0. That is 3 significant figures. The second rule goes along with what we've already said. If it's before a decimal point, after the first non-zero number, it's also significant. So if I have 40.125, I don't know, grams, that number actually has 5 significant figures. Everything there is considered significant. But if there's an implied decimal point, so like you just write the number 100, we don't know. We don't know whether that's supposed to have 1 significant figure, 2, 3. We don't know. It's considered ambiguous. Okay? So it's better to write numbers like that into scientific notation. If I wanted to write 100 with 3 significant figures, I can write it as 1.00 times 10 to the second, because these are the only numbers we look at for significant figures. And now we have zeros after the decimal, after the first number, so that has 3 significant figures. Okay? The last rule says if it's an exact number, so exact number we mean counting or definition. Whoops. My pen's not working. Okay. By counting or definition. So in other words, if we counted the number of people in a room, that's an exact number. That has an infinite number of significant figures because if there are 5 people in the room, there's no uncertainty in that measurement. There's 5 people. Definition is like the conversion factors. So if you go back and think about the metric system, 1 meter is 100 centimeters. It's exactly 100 centimeters. It's not possibly 100.1 or 99.9. It's 100. So that also has what's considered an infinite number of significant figures. Okay? So they don't affect the certainty of the calculation. So let's take a look at these examples. This is just asking us to count sig figs. Okay, so in this first number, 0.04450, those zeros out front, they're leading zeros, so they don't count. But then 4450, that has 4 sig figs. Then we have zeros sandwiched between other numbers, so they automatically count. So we have the 5, 3 zeros, and a 3. That's 5 significant figures. That's a 5. Now we have a definition. 10 decimeters is a meter. So that has infinite significant figures, or it just doesn't count. You can call it that. When we have a number in scientific notation, remember we only look at the part out front. So 1.000, that's 4. All of those zeros are leading, so they don't count. This number would have 1 significant figure. And then here's one of those ambiguous ones. We don't know how many that has, because it has a bunch of zeros. There's no decimal. There's no way for us to know, so we can't judge that. Okay, so being able to count significant figures, while important, is not the main goal. Being able to use them in calculations is where it's important. When you're taking data, when you're collecting data in the lab, you need to use the best equipment that's at your disposal to get the best measurements possible, the most number of decimal places, because that's a more reliable measurement. Okay, and then you use that data in calculations. So if you have to add or subtract numbers, the number of significant figures in the answer will be the same as the number of least decimal places in the problem. So if I add 5.00 and 5.0, okay, maybe I took this on 2 different scales, my answer is going to be 10.0. It'll have 1 number after the decimal place. Okay. When we multiply and divide, it goes by total significant figures as the least in the problem. So let's do that same calculation we just did, but let's do 5.00 times 5.0. So maybe we have, we measured with one ruler for one of the measurements and a different ruler with the other one, and they had different reliabilities. Well, 5 times 5 is 25. That math is easy. But to check our significant figures, 5.00 has 3 significant figures. 5.0 only has 2. So we would report our answer as 25 with no 0.0 or anything, so that it has 2 significant figures. You're going to follow the basic rounding rules for these. 0 to 4, you truncate, which means cut off everything after the number you're trying to round. And if it's 5 through 9 after it, you round up. And then it's best to not round until the final step to avoid rounding errors. I will make an exception for that, though. If you're combining addition and subtraction or multiplication and division. So like say you have to add in parentheses and then divide. Follow the rules for the adding within the parentheses, then follow the rules for dividing at the end. Okay? So I'm going to have you stop the video, try these math problems on your own, see if you can come up with the correct answer to the correct significant figures. And when you come back in the next video, I'll have them up and we can talk about them really quickly.